Hello, I'm so excited to be here today, and I want to share with you a little bit technical stuff, but it's important to help you truly understand peripheral neuropathy. So, peripheral neuropathy affects over 21 million people in the United States, and it's significantly higher when you start to talk about those individuals outside the United States. So it's important that you understand really what peripheral neuropathy is. So today, I'm going to talk to you a little bit about the peripheral nerve, exactly what it is, so that you understand what nerves are being affected when you get peripheral neuropathy. So to give you a background, I guess we need to talk about the nervous system itself. The nervous system is separated into two pieces: the central nervous system and the peripheral nervous system. The central nervous system is the brain and spinal cord, and the peripheral nervous system is all the nerves going throughout the body that are outside the spinal cord or the brain. So these peripheral nerves are the nerves that get affected when you have peripheral neuropathy. So if you have peripheral neuropathy of a single peripheral nerve, you will get symptoms in the area that nerve serves. So now that you understand central nervous system versus peripheral nervous system, let's go to the peripheral nervous system and break it down even a little bit further. The peripheral nervous system consists of the somatic nervous system and the autonomic nervous system. Both of these systems can be affected with peripheral neuropathy. In the somatic nervous system, that is the area that produces the sensation from the five senses, for example, but also produces emotion and movements that occur through the muscles. So the somatic nervous system includes motor nerves, or motor neurons, and sensory nerves, or sensory neurons. Motor nerves, of course, do exactly what they say. They control the functioning of the motor or muscle areas of the body. And the sensory nerves, of course, are the ones that get sensations such as touch, temperature, pain, sound, light, etc. So that's the somatic nervous system. Any of those areas. So you can have peripheral neuropathy that affects the motor nerves, which would be a motor neuropathy, or you can get a peripheral neuropathy that affects the sensory nerves that can be either small fiber sensory neuropathy or large fiber sensory neuropathy. The other system in the peripheral nervous system is the autonomic nervous system. So the easiest way to describe the autonomic nervous system is it's the automatic nerves, or the nerves that control the automatic functions of the body. They control all the involuntary functions of the body, including heart rate, blood pressure, respiration, digestion, bladder function, and even the simple release of oils or sweat to the skin. The main goal of this nervous system is to maintain a state of equilibrium or homeostasis, where all the systems of the body work appropriately together. So they're working in conjunction to help maintain normal functioning of the body. So when the autonomic nerves are affected in a peripheral neuropathy, you will get an autonomic neuropathy. Autonomic being the autonomic system. So you now understand the different systems. So you got the central nervous system, brain and spinal cord, the peripheral nervous system, which is a combination of the somatic nervous system, muscles, and sensory organs or sensory nerves, and the autonomic nervous system, or the involuntary or automatic nerves. So depending on the type of peripheral neuropathy, it is also important that you understand the different parts of the nerve. So if you were to get a good picture of a nerve, I don't really have the ability to kind of show that to you here, but if you could, you basically have a cell body, and looks like it has all these branches or roots coming off of it. One are smaller roots that are called dendrites, and they actually receive information. Then you have a long stalk coming off it, or a long stem or branch coming off it, which is the axon. So you've got the cell body, dendrites coming into the cell body, Then you got the axon going away from the cell body, and the axon can be either lined or not lined. Let me simplify that a little bit. So if you have a electrical wire, you can have a wire that is actually insulated or a wire that's not insulated. The same thing happens for nerves. You can have an insulated nerve or a non-insulated nerve. The insulated nerves have what's called a myelin sheath that allows it to travel more quickly. So it increases the speed at which that nerve can function. That significant oversimplification. If I could show you pictures, it'd probably be a little bit easier. But the whole point here is just to give you some basic information so you can actually get a little bit further into this. So what are the types of injury that could happen that could lead to a peripheral neuropathy? For example, if you're injuring the nerve itself, you could get demyelination. So if you lose that myelin sheath, you lose that insulation, it slows down the signal. The signal's not working like it's supposed to, and it oftentimes will get insufficient signal and the nerve will malfunction, not work like it's supposed to. You can get axon injury. If you injure the branch that's going out or the electrical wire leaving the cell, you can't get signals out. By injuring that, you cut off the signal. Again, you get a peripheral neuropathy. You can also get a cell injury or cell death. That can occur for multiple different reasons. If you get a cell injury or cell death, then what happens is instead of the signal's not traveling right to the cell or from the cell, you actually don't get any signals at all because the cell that's supposed to be sending the signal isn't working. You can also get a situation where you get an insufficient signal. This is a different type of injury. Typically it means that you have a nutrient problem or a protein problem or an enzyme problem or something like that that's actually causing the nerves to not work like it's supposed to. So let me give you a simple analogy that will actually help you understand this a little bit better. Growing up, I lived in a farming community. And in this farming community, even though I wasn't a farmer and I didn't actually live on a farm, they had canals that would carry water to the different areas. And so instead of sprinklers, you have canals that would actually allow you to take irrigation water and work it around to the different farms and get it to the appropriate areas. When this system was working correctly, the water would get to the appropriate place at the appropriate time. If, though, something was interfered with, then it could actually affect how much water was actually getting to the plants, or getting to the farm. There are multiple areas where this interference could happen. One, it could happen up the stream a little ways. So if a gate was lowered that wasn't supposed to be, or a gate was raised on a farm that wasn't supposed to be, even though you may get water, you may not get enough water to actually water your plants on your farm. This would be similar to, say, getting an injury to the dendrites or an insufficient signal that's getting to the cell. In those cases, in both cases, it's actually poor water flow that's getting there, which is causing poor water flow going out, right? You also could have something get into the canal that interferes with it, so it interferes with flow that way as well. So what if the canal was broken and so the water was seeping out? That would be similar to any parts of the dendrite or axon being injured so that they can't get the flow where it's supposed to be because the water's seeping out in directions it's not supposed to do. What if you forget to raise your gate? If you forget to raise your gate, you don't get a signal at all. And so that's like having a cell death where the signal is not getting there. So as you see this, it's kind of an oversimplification of what the process is, but what really is going on is the electrical signal needs to get to the cell body through the dendrites. And then from the cell body, it needs to go down the axon to the next dendrite to an additional cell. And so you can actually flow from, say, the hand or the foot back to the brain so you can actually interpret that signal. But if the signal is slow, if the signal is interrupted in any way, if the signal is incorrect because of injuries to the axon or the dendrites or the cell body itself, likewise, the brain is going to have a hard time interpreting it. So it's important that you understand so you can actually say, okay, where is the injury happening in my cells so that I can actually work on improving my peripheral neuropathy based on what nutrients I'm missing or what things can I do to help the cells regenerate or heal, or what can I do to help remyelinate the sheath so that that cell can actually work at the speed it's supposed to. This is Dr. Brandt Gibson, and this is your introduction to the peripheral nerve. When you get a peripheral nerve injury of any of these types, you can get a peripheral neuropathy. When it's multiple nerves, it's usually a polyneuropathy. A lot of times, for example, in diabetic peripheral neuropathy, you will get a symmetric polyneuropathy where it's multiple peripheral nerves that are affected and multiple peripheral nerves that are failing. So hopefully that helps. And tomorrow we're going to actually take you a step further. Like I said, this is day 1. Actually, technically, this is day 2 of a 30-day process where we're going to walk you through the information about peripheral neuropathy so that you can start working on this from home. If you need additional information, reach out and we can give you that additional information, including there is a 90-day journey that goes into significantly more depth, has graphics, has ebooks, and so forth that can help you with this process.